Okay, so now we're moving on to the solving inequality section. Again, nothing too much involved. Menu solve. So what you do is you basically just type the thing in as you would, but just make sure that when it comes to the actual sign, you go control equal and type in the sign that they expect you to type in. So it's 4x minus 3 plus 3 greater than negative 5, and we go comma x, and they literally tell you x needs to be greater than or equal to negative 2. Well, you can set up your own graph just the way you do, right? You can do it whatever you want, but as long as you show it properly. It simply means anything 2 or greater must be, you put a line there. Now, if the answer is greater than or equal to, it means you can be at negative 2 and greater. But some questions simply means greater, and you can't include the sign. You need to have an open dot. So menu open again. Sorry, not define. I'm sorry. So it's menu algebra. What am I doing? Menu algebra solve. Okay. 8 minus fraction x over 2 greater than 6 comma x. It says x is less than 4. Well, you've got 1, 2, 3, and 4. X is less than 4, meaning x is everything below 4, not including itself. Let's do this once again. Menu algebra solve. Right, 5x plus 9. Again, control. Yeah, you see, I don't use this as often as hopefully the students. Therefore, I'm making a bit more mistake than usual. Familiarity with the questions will come and, help. It will affect you a lot more. So greater than or equal to 7. Well, I'm going to say 7 is here. So 5, 4. There is no one set solution. It depends on the number systems, okay? Oh, sorry, did I forget those at the top? I'm not even going to bother doing this one here. Just can solve. If you want to do this one here, menu algebra. By now, menu algebra solve, you should be able to do it manually. Okay, so 3x minus 1 over 4, that equals to 2x plus 3 over 3. Again, press across, comma, x. Make sure your thing is here, and make sure your comma is here, not here. Okay, you got equal x equals to 15. Okay, and so be clear with what you are actually doing. Now, this one, you don't even need to use a calculator. But if you really want to, look, it says decide if the point is on negative 1 and 4, meaning at x equals to negative 1, y needs to be 4. Well, we're substituting that value into this value here. So 3 times negative 1 plus 7. Does that equal to 4? So 3 times negative 1 plus 7. Does that equals to 4? Therefore, it's true. But if we get up to here, 5 times negative 1 plus 4. Does that actually give us negative 9? Well, 5 times negative 1 plus 4 equals to negative 1. So false. Okay, we'll move on to the graphing section here. Now, remember, to do this particular section, you need to change your mode into something called approximate. When you're drawing graph, it needs to be approximate. Okay, and so what do we got here? Exact value, approximate. Right. Done. And so when you are drawing this graph, hang on. Boom. Okay, so now just listen very carefully. Whenever they say f of x, that essentially is the same as y, something. So if you're panicking, there's no y equals to something. Well, y simply is a function of x, isn't it? this is a function, this is represented by whatever x value is. So we go negative a half, I mean, you literally can write this down, times a half, if you're not sure if that's going to work, equals, that's already there for you. It wants you to find the gradient. I mean, the gradient is automatic. It's negative a half. All right? The y-intercept equals to positive 3. If they want you to sketch this graph, you also need the x-intercept. So you go menu, analyze graph, 0. Actually, no, that's not correct. Menu, it should be trace graph. Well, look, as you can see, they literally tell you the y-intercept is at 3. Okay, so I'm gonna keep on moving around until I get to, there we go. Do you see something called 0? Yes, I do. The 0 simply means that's where your x-intercept is. You simply draw a line. As to the gradient, who cares? As long as you have plotted the points you need to, that's all it matters. Next, find the gradient and y-intercept. Again, let's move on to this particular question here. Now, I think you press tab. No, you simply just press, well, you basically start a new graph. Start a new graph. Now, how would you get into this mode? Right now, it's simply y equals to mx plus c mode. Press delete, and I want you to choose something called relation, all right? Choose something called relation. Once you're here, you can literally go 2y minus 3x equals to 2. And that literally draws you the graph. But if I'm not too clear, with, with the graph itself, I need to zoom in. So you go to menu, you go to zoom, you go zoom in. No, zoom in. And just put the center wherever you want the center to be. You simply do that. Press exit to go back to the cursor function. Now, if your mode is, I need to elaborate a bit. If your mode is not approximate, you'll get massive decimal values. Sometimes you get like 999 over like 4444, something like that. And so once again, we go to trace, graph trace. You go to the right. Okay, y-intercept is 0, 1. Okay, that means it's at 1. X-intercept, you go to the right, 0. It is at now negative. Now negative 0.667 is the same as negative 2/3. Just remember, you are expected to know some of the basic fractions and stuff. It's like negative half is negative 0.2. Okay, this question requires you to know what is the y-intercept and the gradient. Okay, so y-int is 1. The gradient is a bit hard to figure out, because we need to rearrange this equation into something else. So open up a new page here, press this little button here, menu, algebra, solve. Okay, what are we doing here? We are actually solving 2y minus 3x equals to 2, comma, y. Now, why are we using the letter y? Because we are literally solving for x. Rearrange the equation to make y the subject. We are literally saying we want it to be y equals to something. Oh, we get this dodgy little answer. I'm sorry. That doesn't look right, does it? So we go to File. So if you press Doc, you go to Setting. Again, you go to Document Setting. And you literally can go back down to Approximate and go to Exact. So once again, you need to be able to switch between, exact and approximate, and that's the challenge of this question here. Oh, well, you see, that's a completely screwed up thing. Go back to the equation itself. Remember, see what I did. Replay the video if you want to. I tried to replay this. That's not going to work because it's already in the decimal. You need to go back to the original, and you go enter, and then they would have the equation rewritten as y equals to 3x plus 2 over 2. If you want to simplify this one here, it simply means 3 over 2x plus 1. And so our gradient would be 3 over 2. Okay, let's move on to this one here. Sketch the graph using linear relation and find the x and y intercepts. Well, this is actually quite easy. It doesn't require us to figure out what is the gradient. So simply draw the graph. So Control N, you press no. You want to delete everything. All right, too much hassle. Choose graph. Right, so you're gonna go 3/2 x minus 2. Boom, the graph automatically gives it to you. Menu, trace graph. Well, they originally, what's going on here? How? There we go. No, we don't. There we go. So you press exit. Do not panic. Press exit to get out of that page. Now, if you move this around, they immediately tell you, oh, the y-intercept is -2. If you don't know how the graph is drawn, who cares? The exam doesn't require you to actually, the examiners do not need to know you don't know something, okay? So you simply keep going to the right 0. Well, your thing here is 1.33. Now remember, 1.33 is basically the same as 1 1/3, which is 4/3. I mean, that comes from familiarity of your things. But then again, nowhere here said you must have the exact value. So I mean, we're not gonna be too harsh. Hopefully, at least not for the labeling. Okay. So your x and y intercept is sketch that of the following by finding. Well, we already. Oh well, look. If you really need, you actually want to actually say x intercept is at 4/3, y intercept equals to -2. All right, something like this. And so here we move on to this particular graph here. Again, you want to start a new page so that it doesn't, so you don't get confused with what you actually have to do. Okay. And so again, we have this situation where you're required to draw, where it's got x and y both together. So you take away, you go to relation or press 6. 3x plus y equals to 3. Boom, the graph is drawn for you. Menu, trace, graph. I mean, they normally start off on, okay, so the y-intercept, we figure out the y-intercept is at 3. What is the x-intercept? Oh, x-intercept is at 0, it means 1. So this one is actually quite exact value, right? And so this is where you actually say x-intercept equals to 1, y-intercept equals to 3. Nice and easy. I mean, these ones here, you don't even need to use your calculator. If it's x equals to some graph, it means it must be a vertical line. So at 5, boom, make sure you show the the intercept. Y equals to something generally means it's a horizontal line across at -1. -1 here. Y equals to 4x. Anything without a constant, it goes through the middle. But to differentiate that value and that value here, make sure you plonk a point in there and say, and let's just say x equals to 1, y equals to 4. Substitute the value of x into it. So you got 1, so you got 4. Put a bracket, 1 corner 4. You usually use 1, so it's the easiest one to deal with. Okay? And so when you are here, look at it. It's a negative graph. It must go through the middle here. That's a terribly drawn graph. Because you don't actually have any intercept other than the origin, you need to substitute a value of x in there, y equals to -1/2. And so 1 is here, -1/2. And so put a point in there, 1, -1/2. Okay, something like this. I think I'm going to pause this video and move on to the next one here for the third segment. We're nearing the end of our little topic here. Okay, so we'll move on to the next little topic here. Yeah, I think I'll come back in the third part.